So on this chapter 1 and 2 practice, he's just asked me about number 5, which, yeah, that's a good question. It's a little chart of x's and y's, and they are decimals. Some decimals in there, but it's really just kind of ordered pairs. It's 23.8 and 62.5, 28.2, 51.5, and 37.0, and 29.5. So the question is, find the equation of the line that satisfies this data. So you're supposed to find the equation of the line. That's kind of a classic question. I can see how, maybe you were confused. Again, I'm getting the vibe that you guys are pretty darn smart class. But anyway, we'll see after today's quiz. When someone says find the equation of the line, there's a lot of ways to ask that question. There's a lot of data I could give you. Anyway, one classic question is I give you 2 points. If I give you 2 points, you can get the equation of the line. If I give you 2 points, you can, step 1, find the slope. And once you have the slope, you got a slope and a point. You use the point slope formula, you get the equation of a line. Well, essentially, that's what this is. Although it just seems maybe a little different. It's in chart form, and you don't realize you have 2 points, but you do. You actually have 3 points. You actually don't need 3 points. You only need 2 points. So really, this question is, here's 3 points. Please use 2 of them to get the slope, and then get the equation of the line. That's really all this is. And so, but just when it's presented like this, students look like they think it looks different. But but I'm getting the feeling you knew this. So it is 2 points. I'll just use these 2 points, these first 2, and I'll do my slope. My slope is the change in y over the change in x. So I have to subtract, however I want to do it. Listen, I'll do it this way. I'll do 62.5 minus 51.5. But if I subtract my y's that way, then I better subtract my x's that way. So I have to subtract my x's that way. Is this bothering you? Did you guys subtract the other way? Is that what you did? Mm-hmm. Okay, that's okay. The point is, I hope you realize it doesn't matter. As long as I do this consistency. If this y subtracts this y, then I better do this x subtracting this x. But I could have done it the other way. You're probably used to doing it the other way, but that works. I would probably pick up a calculator. I think that numerator is an 11, and the denominator is a negative 4.4. That's right. 4.4. 4.4. And then, you know what, you might just say, okay, there's my slope. The truth is, I'd pick up a calculator and divide that, and I bet it's nicer than you might have thought. If you divide that, what is that slope?
Negative 2.5.
Negative 2.5. So that's my slope. It is negative. The numerator was positive, the denominator was negative. If you would have done it your way, your numerator would have been negative, your denominator would have been positive, but either way, the answer is a slope of negative 2.5, but that's not the final answer. I want the equation of the line. Now that I have a slope, I can take the slope at any point I want. I could use the top point, the middle point, or the third point. But I can use a point and a slope and get the equation of a line using my point-slope formula. I'll use this point, if you don't mind, and I'll go like this. Y minus the y value equals the slope, negative 2.5, times x minus the x value. That's step 1, finding the slope. Step 2, using the point-slope formula. And I could have used this with that point, or that point. It doesn't matter. It's so cool. By the time you distribute and add and clean it up, we all get the same answer, regardless of which point we use. We all should get the same final answer. I would not call this the final answer. I would distribute and add. This is decimals, so a calculator would help you add and distribute and multiply and everything. So I would use a calculator to help me. That's a negative 2.5x. I think when I multiply that negative times that negative, it's positive something.
92.5.
92.5, thank you. And then I got one more move. If I'm trying to solve for y is how I want to leave my answer. So I'm going to add 29.5. Add 29.5. Are you guys okay? And I get negative 2.5x plus.
63. That's not right.
Adding.
Yeah, I had my positive sign was back wrong.
Okay. Right. So this is
22. Yeah, 122.
Oh, 122. All right, you guys. That's it. I guess I sort of helped you.
I did it a less complicated way and got the same answer.
No, I don't know if I believe that.
Why not?
Well, what do you mean by there's kind of only one way to do it? Now, I think I could know what you mean. What do you mean, though?
I took a point, one of the 3 points, and I plugged the x in for x and the y in for y, and the y equals mx plus b form.
Yes.
And then I solved for b.
Yes.
Yeah.
Yeah.
I think that's a lot easier than trying to remember that.
Yeah. Yeah. Okay. Let me explain. You want me to explain what she said? Hang on. Any other questions about this, though? Are you guys happy with this? Let me explain what she said, because this is true, and you may know this already, or maybe you don't. But when I say find the equation of the line, I feel like I need a point and a slope, and if I have a point and a slope, I use my point-slope formula. But she just described something different. She wants a point and a slope also, though. But if she has a point and a slope, then she likes to use this formula. She just told me. And watch how she uses this formula. Here's what she does. She doesn't know the y-intercept. She does not know b, the y-intercept. So what she does is she knows the slope is negative 2.5. And then if you know a point, you can take any one of those 3 points. It doesn't matter which point. But you can plug it in for y and x. So I'll take the 29.5 and plug it in for the y. I'll take the 37 and plug it in for the x. And then I'm plugging it into this formula. Now the funny thing is I don't know b. But if I plug in that y and x, and I do know the slope, can you find b? Yeah. This is a little different way of doing this problem. I can take the slope and a point and plug it in like this and get b. Watch. Multiply that for me, please.
92.5.
That's that negative 92, what'd you call it? 92.5. And it is negative. This is 29.5. Over here is your plus b. We're going to try to find b, so what are we going to do? Add 92.5. We're going to add 92.5 to that 29.5, and we're going to get 122 equals b. So that's one way of finding the b. Now that you found b, you should write your answer. Your answer is this equation without the y and the x filled in. You want the y to be a variable. You want the slope, which is negative 2.5, times the variable x, and now you can fill in your b. So that also works. Maybe you did that. Maybe you know that. Maybe you learned that somewhere in high school, somewhere. I don't know. That's fine. I kind of got attached to this point slope formula somewhere in high school or 5th grade or wherever I did this. And so I kind of teach this, but I do know about that other concept. She said that's easier. I don't know. You know, one thing that's easier is she doesn't need another formula. I make you memorize this other formula, I guess. She gets away with just kind of knowing one formula. You know?
That is the problem. I do forget the other one.
So, any questions? I mean, there's more than one way to do things sometimes. And okay, so that was number 5 from our little worksheet. I just helped you with it. But again, it wasn't anything new, but it was maybe it was presented in a new way, though. Maybe you hadn't really seen it presented like that. But you really just had a couple points, in a way. Any other good requests?
Number 7.
What'd you say?
7.
7 is cool, dude. It's really, again, I want to say it's sort of the same thing. But it's a word problem, but I think it's 2 points. If you read that word problem, I think it's 2 points. What does it say? It says a businesswoman sells outfits in the mall. If she sells 52 outfits, her cost is $845. See, I feel like that's an X and a Y. I mean, I'm gonna write it like that. She sells 52 outfits and it cost her $845. And they kind of go together like an ordered pair. As I read that problem, that's the feeling I got, and so I wrote that down. Then it says, when she sells 100 outfits, her cost is this. So then when she sells 100 outfits, her cost is $1,025. Then it goes on to say that this cost function is linear, and therefore there's a line that connects these 2 points, and they want the equation of this line. They said, what did they say? Find the equation of the line that models this cost function. So really it's the same problem. If you're given 2 points, can you get the equation of a line? I'll help you again though, maybe, if you want me to. I would do the slope, and the slope would be the 1025 minus the 845. Is that cool? I'm subtracting that way. So now when I subtract these x's, 100 minus 52. Y's always go on top of the x's, so don't ever screw that up. I would pick up a calculator. Calculators help me, you guys. This is some number, 200 and... No, it's not. 180 over 48. Thank you. 180 over 48. And you could say, damn, that's my slope. But the truth is, I would pick up a calculator and divide it. And it might be a nice decimal. What is it?
15 over 4.
Well, okay. It's 50. He reduces it. It's 15 over 4. I mean, that's cool, too. That's a reduced fraction, 15 over 4. I'm saying I would go with the decimal. 3.75. Maybe... because it's kind of a word problem and it's sort of about money and business, maybe that's what makes me want to do the decimal. You know, I feel like I'm talking about dollars and cents here, maybe. I'm not, you know, I don't know.
That's why I kept messing up, because I would leave it as a fraction. And
Yeah.
have these huge fractions everywhere.
Yeah.
It's like, you just reduce it to 1, or 375 over 1, it makes everything yes.
Right. Like this was a nasty, right, like if you left this, I got you. You left this as your slope.
Yeah.
Well, actually, brought it up to like 48 or whatever.
Or you did something
Yeah,
different.
maybe like even higher, so it's...
Yeah. Why, how'd you do that? By getting rid of this decimal?
I put that in my equation way, and it came out like really huge decimals over fraction.
I made it 22, 55 over 22. And then when I put that into the slope intercept, then I have this huge, like 1,000, or like, the y-intercept was like 980.
I wonder how you got 55 over 22 though.
I multiplied both by 5.
But why, I wonder?
Because it takes the decimal out of the bottom.
Oh, okay. Okay, thank you. I understand now. Yeah, you're doing a little manipulation to get rid of this decimal. Right. Anyway,
Yeah.
we do have calculators, right? I got you. So we forget maybe that, I mean, I don't know, maybe we're used to doing math without calculators and playing around. And anyway, but we can divide it and get a nice decimal. But I see what you're saying. Like, listen to me a second. He's trying to say, let's multiply the top by a 10 and multiply the bottom by a 10. That makes it 110 over negative 44. Now, why did I multiply by 10? To move the decimal over one place. That was my purpose. But now I have this fraction, which reduces big time. You reduced it to 55 over 22. The truth is, I can divide 11 into that and reduce it even further. It would be 5 over 2. And by the way, 5 over 2 is 2.5. So this all is the same. All these are 2.5 to tell you the truth. You know, that's the beauty of math. But anyway, this would have been a little nicer. Working with the most reduced fraction you can is a little nicer than a non-reduced fraction. So, but making it a decimal might be even nicer than that. But you got a little freedom to do your math. I mean, I'll accept, you know, as long as they're right, I'll accept the decimals or the fractions. And in some cases, maybe I've tried to teach you to work with fractions. But, you know, when this problem has these decimals everywhere, that really tempts me to go with decimals. And again, this had like dollars and it seems like a word problem. That kind of makes me tempted to go with decimals. I got you. But you guys are thinking fractions a little bit. Hey, now that I got the slope, what should I do? I'm doing my, well, either way, right. We learned her new way. You can get the equation of the line kind of using her way. You can get the equation of the line using my point slope formula. Either way, I'm going to go back to my old habit. I'm going to go y minus the 1025 equals the slope times x minus 100. It does make me memorize this formula at all, but then the steps of finishing aren't too bad. The steps of finishing are always distribute this and move this over, kind of. You know, that's always kind of the steps to finish. If I do distribute the 3.75, it's 3.75x minus 375, I think, when I distribute that. And now I'll add 1025. I'll add 1025. I'll pick up my calculator, and my answer is y equals 3.75x plus something.
1400.
Well, he's negative and he's positive. Be careful. 650? 650. Thank you. So anyway, it's just, I don't know, a lot of this same thing. Here's 2 points. Find the equation of the line. It was in data form. Here's 2 points in word problem form. But it's the same problem, you know. You know what? I want to point out, if this is her, this is this lady. I just to get back to the word problem a second. This lady's making these outfits and this is her cost. It's not really, nothing here is about what she sells them for. This is just her cost. So let me ask you this funny question. After we're done with this problem, what is her cost when before she even makes any outfits? Right, in other words, if she makes 0 outfits. And if she makes 0 outfits, you would plug a 0 in here, and this is her cost. That is what we created a cost equation here, because the y values are cost. Anyway, if you plugged a 0 in, it would be 650. So that 650 is her initial kind of cost. I guess that's her cost of renting her building, buying her sewing machines, you know, I don't know, whatever, before she even made one dress or one outfit. Every time she makes an outfit, how much does it cost her to make an outfit?
3.75.
That's what that slope is. That's that rate. It's the cost per outfit. Yeah. That's the initial startup cost, and that's the cost per outfit. It's cool to know all that, you know. I mean, that's sort of some of the stuff we've been talking about. We just have linear equations, slopes, and y-intercepts, but they have meaning. In the real world, they might have some meaning there. Right. What else? Any other requests or concerns on this stuff you've been working on? 16. Oh, okay. Okay. 16. All right, so 16 on this piece of paper is they give me a function. It's y equals -2 parentheses, x plus 25 squared plus 18. X plus 25 squared plus 18. And basically it says sketch a graph. And then it says label the minimum or maximum point on the graph. Well, you guys, we just learned this yesterday. You might not have had time to practice it too much, but this is one of our basic functions. We learned 5 basic functions and how to shift them, and this is one of our basic functions. He is, what would you call him? You got a name for him? He's a parabola. He's that parabola. He's that squared function. Maybe you'd call him the squared function, but his shape is a parabola. And we're going to be studying that a lot in chapter 3. But anyway, right now, he's been shifted. And how has he been shifted? Let's discuss his shifts. Let's just write down some words. How's he been shifted?
Left 25.
She said left 25. You guys agree? Left 25, is that right? Left 25, that is right. Yep. What else?
Up 18.
Up 18, up 18. It's been shifted up 18, left 25. Anything else?
He's upside down.
That negative sign means he's upside down. And I kind of told you I wasn't going to do too much of this to you, but because there's a 2 in front of this, it has been vertically stretched. Now, so he's a little skinnier, but that's all so subtle that you can almost ignore it. I mean, but it is true. The multiplied 2. Maybe I put it there so you would, to try to trick you. Teachers don't really try to trick you.
I just didn't know how to show that.
Well, I know. That's what I'm saying. That you don't know how to show it. I don't know how to show it because all it is I'm saying it's a little skinnier. It's been stretched. It's like you grabbed the ends of the parabola and pulled them up a little bit and it got stretched and it became a little skinnier. But you're just going to draw a rough parabola anyway, so you just try to draw a little skinnier. I mean, it's a nice thing to know, but it's hard for me to grade if you did it skinny enough or not. So I'm not really grading you on it. Right. I tell you again though, by putting it in there though, I'm sort of testing whether do you think. I mean, I'm tempting or testing you to see. Hopefully, you're not going to say that 2 is a shift down 2, right? You're not, or a shift to the left 2, or a shift to the. I mean, I'd like you to know that the 2 is not those things. I almost don't care what it is, but it's not those other things, right? The 18 is a shift up. The 25 is a shift left. The 2 is not one of those shifts. No, it's not, right? Is really what I want you to know. Anyway, I can easily graph this now, I think. I think I can take my basic parabola, really, and one more time, it lives here like this, but I think I can take it and do what it says. Up 18 to the left 25, and then he is flipped upside down and maybe a little skinny. So, are you happy with that? Okay, and one more time just to fill in a couple details. What did I do? I went up 18, so I think I'll label that 18. I went to the left 25, so I think I'll label this middle right here negative 25. I know in the problem it's a plus 25, but we do know it's left 25. If you go left, this is labeled negative 25. And then I was sort of asking you to label the minimum or maximum point. Do you see the minimum or maximum point? I hope so. There's no minimum, but there is a maximum right there. And what would you label that point?
Negative 25, 18.
Thank you. I mean, it's easy, but sometimes it eludes us. We're staring at all this stuff. We don't know what to. Yeah, yes. I guess I'm asking you to label that point, or maybe use the word maximum. You tell me. There's a maximum at negative 25, 18, or somehow we're communicating what that maximum is. Are you guys okay? We learned that yesterday. That's cool. That's good. That's good stuff.
I have a question on number 13.
Okay, yeah.
I I pretty much have everything. None.
Yeah.
I don't know if that's right.
Okay. That's a good thing to talk about. And this is this funny little. I designed these questions. They're kind of from 2.1, if you don't mind. There's this 13 is a picture of a function, and it looks like. Let me ask you. It's a little picture of a function. I can draw it, but I'm sort of want to know what's that center point. And center may not be the exact word, but maybe you know what I mean. Can you tell me what point that is?
3, 2.
Good. It is over 3 and up 2. That's what I see. And that's sort of the center point, but it's the center of this cubic thing. And so this cubic thing comes up like this. It sort of levels off for a second and then continues on up. So it's a cubic function that normally was be over here, but it's been shifted over maybe and up, I guess. Been shifted over and up. So here it is. Now this question wasn't asking about shifts, but it's just asking about when is it increasing, except it starts with decreasing. Hold on. When is it decreasing? When is it increasing? When is it constant? And do you see a min or a max? And now I finally understand what her question kind of is. Or she said she had none filled in on a lot of these. Do you agree with her? I do agree with her. I think none is the answer to a bunch of these. Like, when is it decreasing? When is it decreasing? Never, huh? I mean, again, reading left to right helps us decide about increasing and decreasing. And reading left to right, I would say this function is increasing. So when's it decreasing? Never. Okay? Never or none. I think I told you to put none or never. All right, so when is it increasing? The whole time. I mean, you make, and the way the picture looks, it looks like it's sort of flattened out there, but it didn't flatten out long enough to call that constant. It only was flattened for a second. And so I would say it's increasing forever, always. It's always increasing. How do I really want to say that?
Negative infinity, infinity?
Yes, yes. I'm asking for an interval where it's increasing, and you're right. It would be all real numbers or negative infinity to infinity. But so now when is it ever constant and leveled out? Never or none. What do you see, a min or a max? No, I don't see a min or a max. They're both nones too.
Did you say infinity?
No, we don't want to say infinity. Because the min or max, if you remember, the min or max we list as a point. And if the answer is infinity, it's not really a point, so we just say none. Yeah. So this is the none problem.
Yeah, I was arguing with a friend about that. I'm like, I think it's none, and they're like, no, it has to be an answer. And I'm like, no.
Yeah, right. Especially if the directions say, if none, write none. That doesn't mean there has to be an answer, right? It means none is a possibility. But these things are arguable. You're right. We could have arguments if you want, but we try not to, because I'm usually right. But some of these things are kind of arguable a little bit. But it's good to all agree before the test or the quiz to agree what we're discussing. Yes, ma'am?
Is neighbor 12?
Yeah, so his neighbor is 12. Sure. It's kind of a lot like this thing in a way, but it's different. So 12 is a picture, and it's got those same questions. And 12, though, is a picture with those same questions. This time the picture is an upside-down parabola. Again, you help me, please. What would you call the vertex of that parabola? And by the way, that's probably a brand new word for you, but that is what we call the max or min of a parabola. We call it the vertex. But anyway, where is it?
8, 6.
So over 8, and up 6 that's kind of where you clearly see the max. Is that what you're telling me?
Yes.
Okay, thank you. I mean, that's your job, is to read the graph and find those numbers. Thank you. And so that's the picture of it. And here comes the questions. When is it decreasing? When is it increasing? When is it constant? When is it a min? And when is it a max? Right, so these are good questions. Again, this time it might be a little more interesting. When do you think it's decreasing?
8, infinity.
So before 8, it's on its way up again. So before 8, it's increasing. After 8, it's decreasing. Thank you. But now how do I say after 8? I say it like she said. She said from 8 out to infinity. It's kind of hard to write an 8 and an infinity.
Yeah.
In the same problem.
My hand keeps wanting to go sideways, so it's like diagonal.
Weird, yeah. It looks weird even. I can't even look at that. What language is this? That's 8 to infinity. Okay. When is it increasing? From negative infinity to 8. Okay. I think so. So that's cool. When is it constant? It's not. Never or none. Or never. Right. Good. Does it have a min? No, it doesn't have a min, but he does have a max, and we list the max as a point. This is not an interval. These guys are intervals, but these two are points, and the max is 0.86. That's an 8. Cool. Pretty easy in a way. It's easy. You know, your homework is like this. You know, your homework is different in the sense that they don't make you fill all this in. They've got multiple choice versions of these questions when you're in 2.1, but it is the same concepts, but you get to pick multiple choice. So, yes.
So I don't know if it's because you said it. I wonder. So min and max. If I write it 6 at 8, is that still, or is it actually the point?
I got you. I don't really like talking like that. I did say that one day, and what I was doing was I was worried about how the homework was worded in the
Okay.
computer homework.
Oh, I see.
Yeah.
Okay.
So for me, I'm really looking for a point. The max is a point. Please write it as a point. Now, my directions sort of say that, I think. Write them as points, or find them the min or max points. Yeah. But anyway.
Okay.
But intervals means
What?
the interval, it says find the open interval, so when we write an interval form, it is point.
All right. Now,
Yeah,
no, hang on. So when is it decreasing, increasing, or constant? The answer to those are open intervals. And when is it a min or a max? The answer to those are points.
Okay.
And intervals are not points. Intervals are not points. But they both use parentheses and a comma. So god dang it, it might be confusing. An interval might seem like a point, or a point might seem like an interval. Right? And I sort of tried to say this the other day. I said math is a beautiful language where everything is well defined and there are no contradictions. But here's one place where you could get confused and you could feel contradictory. These parentheses with a comma, does that mean an interval or does it mean a point? And I tried to say that from the context of what you're doing, it should be clear. But it is a place where students could confuse the two notations, because the notations are very similar, but they are two different ideas. Because an interval is an interval on the x-axis, and a point is a point with an x and y coordinate. So it's two different things. And you're nodding, you understand.
Yes.
Right, right.
We should make a new symbol.
Huh?
We should make
Make a new symbol,
put on
right,
it.
right. Well, one way to avoid it is don't use interval notation. And what would I say instead of interval notation? I think I would just say x is greater than 8. You know, that's one way to say that. Or on this one, x is less than 8. I mean, but I'm asking you, I think I'm asking you to use interval notation. I think the computer wants you to use interval notation, so we're pushing this interval notation, but and it's really not, especially when you see infinities in there. Those aren't points. I mean, we know that's not a point. That's an interval from 8 to infinity. So, hang on just a second. So I just made up a function. If I asked you when it's increasing, what would you say?
2 to 4.
Hey, can I change this problem? All right, I'm sorry. All right, hang on. Bear with me here. Bear with me here. Bear with me here. Bear with me here. Okay, here's a function. It's got some weird stuff. Looks like it's kind of weird. I don't want to make it too weird. But now, here I go again. When is it increasing? And you would give me an interval, I hope, because then the word increasing implies I need an interval, and the interval would be on the x-axis from 2 to 4. Do you agree? Mm-hmm. So you would write that as an open interval from 2 to 4. Okay? But if I asked you, when does it have a min, and I labeled this 4, now, when does it have a min? At the point 2, 4? And how would you write the point 2, 4? The same damn way. So are you confused? I hope I'm confusing the hell out of you. No, I'm trying not to confuse you, but that could be confusing, right? But I think from the words, you know the difference. Look, when you read the words increasing, you're supposed to know, wait a minute, that ain't a point. Increasing is an interval. So this is the interval 2 to 4. And a min or a max is a point. So this is the point 2, 4.
That's a y.
That's a y value. This ain't a y value, right? That's an x value, right? These are two x values on an interval. This is an x and a y value. But they sure look the same, I know. Anyway, I'll try not to do that to you. But that's good. That's a discussion. Just one more time. That's an interval. That's a point. They're different. These are different answers. What else? Anything else bothering you anywhere? Yes?
So you wouldn't use, in number 12, decreasing, increasing, you wouldn't use the bracket for the 8?
So, I don't know, that part's debatable too. When it is, okay, so the answer to decreasing and increasing are these intervals. And the intervals are from 8 to infinity or from negative infinity to 8. And so now the argument could become, do we want to include the 8 or not? And if you did, you would make it a bracket. Well, we don't. Because...
So it's two separate points, that's kind of the idea.
It's just that at the 8, when you're at the 8, is it increasing or decreasing? And that question doesn't even make much sense. At one point,
So it's 2 points.
so I'm saying at 8, I can't decide what it's doing, so I'm claiming that it's increasing and decreasing all the way up to 8, but I'm not going to include the 8 because that confuses me too much.
That's fine with me.
No, but does that, I'm not including the 8 because I'm at 8, I can't decide which one he is. But before 8, I can definitely say it's increasing. After 8, it's decreasing. And I don't need to include the 8. We like to write these places as open intervals. And the homework does that to you. See, in the homework for 2.1, they would have this question, and they would be multiple choice, and they would have that as one answer, and they would have that as another answer. And you know, I tried it. I was doing some. I tried to put this one to see what it would do, and it marked it wrong. And the hint was, please, we want open intervals, and open is meaning doesn't include the endpoint. So then it told me, oh, they want an open interval, which does not include the endpoint. So
Good thing it gives you 2 chances, 3 chances.
yeah, right. Actually, you can make 100 on that homework. You can go back and do it an infinite number of times and make 100, right? Eventually. All right. What else? Any other good questions? What'd you say? 4. 4. Well, yeah, and yeah. Yeah, let's talk about that. And then we're winding down here. We might get ready to take a little quiz. But number 4 here. It's f of x equals 3/8 x
Minus 87.
minus 87. Okay, thank you. This is a good question. Watch what it. Okay, so part A says, what's the slope? I think. So what's the answer?
3/8.
Thank you. 3/8 is the answer. I mean, you're smart. You know that. You know that. Right. That's just y equals mx plus b. Right. That's all that is. Y equals mx plus b. I didn't write y. I wrote f of x, but we know they're the same. Okay. So cool. And then part B says, what's the y-intercept? So what's that?
Negative 87.
And you can just write negative 87. That's cool. I've been sort of preaching that I like the y-intercept written as a point. If you wanted to write it as a point, what would you write? 0, negative 87. Right, that's on the y-axis. Right, you're right. Okay, cool. But I'll accept both. I'm not that picky there. But, okay, awesome. Okay, so what's part C say? What's f of
48.
48? So hopefully you know what that means. That means
Plug in 48.
plug in 48 for x and find the y value. Right, that's what that is. Plug in 48 for x and find the y value. So it's not that hard. I would kind of do it right here, I guess. 3/8 times 48 minus 87. So that, anyway, you can pick up a calculator. You can make this a decimal. But I don't know. I would do this. I would cancel the 8. That would be a 6. That would be 18 minus 87, which is negative 69. All right. That's the y value. That's the answer. The answer is that y value. Okay, this is fun. Listen, part D. Part D says,
0.
find the 0 of f of x. And a lot of students, so these questions are my questions. I gave it to you as a practice. The reason I gave it to you as a practice is because these things show up on tests. And in the past, when this thing shows up on a test, students all over the place, they miss this D. They miss this D. They shouldn't, but here's what they do wrong. They plug in a 0 for x. That's wrong. If I wanted you to plug in a 0 for x, what would I write?
X-intercept.
Well, I might just say f of 0. I might say, please find that, which means plug in a 0 for x. But anyway, that ain't what this is. This is different. The 0 of a function is when the function equals 0, which means the y equals 0. Right. And I'm looking for the x. The 0 is the x value that makes the function equal 0. What did I say? The 0 is the x value that makes the function equal to 0. So I'm plugging in a 0 for the function, and I'm trying to solve for x. Maybe you just remember, maybe that's a good way to remember. Maybe it's good to just remember a 0 is an x-intercept. And so I'm going to let y equal 0 and find an x-intercept. not sure. I don't know. Hey, but it's not that, because you know what that is, by the way? What is that when you plug a 0 into the function? When you plug a 0 in for x, what are you getting when you plug a 0 in for x? You're getting the y-intercept. You're going to get negative 87, which I've already asked you about. But right, so anyway, don't do that again. So this is the x-intercept, or the 0 of a function. Move the 87 over. That's how I do it. And then I multiply by 8/3. Is that what y'all do? Mm-hmm. Multiply by 8/3. So x equals 87 times 8/3. Which means you can multiply by 8 divided by 3. Anybody?
6 minus 6. Divided by 3.
Oh, divided by 3. So don't forget. Okay, then divided by 3. 232. Is that okay, you guys? Mm-hmm. Cool. Listen, he asked me this question, and I wouldn't doubt that so far, so good. I wouldn't doubt that what he really kind of wanted was help with E and F. And that's probably what y'all want help with. But anyway, that was easy and cool to go through this, just to confirm how darn easy it is. And by the way, E and F are easy too, but they're worded a little funny. They want an interval. It says, I want an interval when f of x is less than 0. I want to know when the function is less than 0. Listen, you guys, when I wanted to know when the function equaled 0, what did I do? I set it equal to 0. Well, if I want to know when the function is less than 0, you know what I think I'll do? I'll write the function and I'll set it less than 0. I mean, when I want to know when it equals 0, I set it equal to 0. When I want to know when it's less than 0, I guess I'll set it less than 0. And then I'll proceed to solve this. Now, what's interesting is you'll move the 87 over and you'll multiply by 8/3. So, what are you going to get? You're going to get that 232. But it's not going to be equal to 232. It's going to be less than or greater than or whatever the problem is. If you do move the 87 over, watch this. Do you leave the inequality like this? Is that what you do? You don't switch this inequality, do you? No. What about when you multiply by 8/3? I'm going to multiply by 8/3. I'm going to multiply by 8/3. So x, do I switch the inequality now? No, I don't. Thank you. So I multiply by 8/3 and I get 232. And I guess the answer is, when is the function less than 0? The function is less than 0 when x is less than 232. I guess that's my answer. Oh, they wanted an interval. Okay, guess what? That's sort of an interval, but if I wanted to write that more in interval notation, what would I write?
Negative infinity to 232.
Yes, sir. Yes, sir. Right. So without doing part F says, when is the function greater than 0? You could do it. You would set up a greater than problem. Guess what the answer probably is? When x is greater than 232. Right. Let me show you something else. I mean, we discussed inequalities in section 1.6. And so this technically was a little baby inequality here, you know, is what it was. But it wasn't very hard, but you weren't sure what I wanted maybe, but now you know. So you know how to solve inequalities, no big deal. Sometimes I like to teach inequalities very graphically or visually. I don't know if you're going to enjoy this, but watch this anyway. Pretend we didn't do E and F. Pretend I didn't do E and F yet. Okay, so I've got this function. Let me see. What did I find so far? Did I find the y-intercept? What's the y-intercept? Negative 87. Okay, check this out, you guys. I found the y-intercept. Did I find an x-intercept? Did I ever find an x-intercept?
Yeah.
That's technically the 0 of the function, right? That was this 232, was when the function equals 0. So watch. So So the x-intercept is way over here at 232. 232. So there's a y-intercept, there's an x-intercept. If it is just a line with a slope. So there it is. This is a picture of this function. Now, I want to ask you this very visual question now. Watch. I want you to look at that and tell me, when is the function less than 0? So, and what that means is, when are the y values less than 0? I'll tell you what that means. It means, when is it below the x-axis? That's what less than 0 means. So when is this function less than 0? When x is less than 232. See that visual way of looking at it? When is the function less than 0? When x is less than 232. When is the function above 0 or above the x-axis? Right. When x is to the right of 232, or when x is greater than 232. Sometimes you can do inequalities visually if you have a graph and an x-intercept. It's kind of, the key might be that x-intercept. When is it above and below 0 is what I was asking. Anyway. Let's quit. Maybe it's 11. Let's maybe just a 5-6 minute break and come back and do a quiz. Let's do that. I mean, we don't need much of a break, but a little 5 or 6 minute break. You know, listen, on quiz or test day, I do kind of like you to spread out a little bit. I mean, this is not a real full class. You're already very naturally spread out. But maybe you guys, when you have 3 in a row here, maybe one of you could jump up here or somewhere. That would help. But we'll spread out. We'll put things away. You can have a calculator and all. We'll come back and take a quiz.